Good afternoon, everyone. I welcome you all to the second free webinar series organized by the Healthcare Engineers Forum of CAHO. Today's topic is on backup power supply solutions. And we have a very eminent speaker today amongst us, Mr. Bijo K. John, who's the founder and principal consultant at TriTech Engineering, Kochi. He is basically an electrical engineer by qualification, and he has a wide experience for more than 32 years in the field of engineering and designing. He has been part of several LEED certified green buildings, providing training in MEP services, CAD and BIM implementation. And he is also a respected member of the ELCA, ISHRE, and IPA. And also, he's also a member of the BIM Association. So I welcome you, sir, today for the webinar series organized by the Healthcare Forum. I leave it to you to go ahead with your talk.
Thank you, Adel. Thank you so much, and thank you to the thank everybody to be for me to be part of this your team. So I'll start with the first slide. Basically, the topic, as you have already mentioned, it is regarding the standby power supply system for healthcare facilities. What are the critical departments? I mean, the major departments in a hospital, like the outpatient, the inpatient, the diagnostics, of course, the emergency, and the theater pre- and post-operative and intensive care areas. Practically, these may be physical spaces. These may not be physical spaces also, because it may be working as separate, grouped units also. So that's the first slide. I just want to, what are the departments and functions in a hospital? So these are aspects which need to be taken into consideration for the power distribution as well as the backup systems. And why standby power is critical? Why backup power supply is critical is because it supports the life support systems for the patient. And every surgical and clinical procedure is depending on power. Again, the monitoring of patient health is also part of the power supply system. Apart from this, you also have the the high value medical equipment which need to be correctly protected, and power should not fail, which may result in preventative cost, extremely expensive shutdowns and maintenances. And also to ensure safety and security systems are working properly, you need power supply. And apart from this, you also have the critical building services, which need to be maintained during the power outages. So this is the third slide. And this slide, I am just trying to explain the reasons why the power blackout happens. So if you look at the graph, you have the weather, the equipment failure, human error, explosion, cyber attacks, and of course, big portion is the human error. So you can see that power blackouts can happen to both due to internal and external reasons. Internally within the building and within the system itself, and externally because of uncontrollable reasons. So what is important is the backup power supply system, which should transfer power to the emergency power, whichever system that you are depending on. So. And power restoration using generators generally take 15 to 45 seconds, which is based on the operating format of the generator sets. So this is regarding the reasons for the power blackout. And if you look at the typical, healthcare load profile, you can clearly see that the majority of the loads are basically the HVAC loads. And of course, the medical equipment, air handling equipment, lighting, the lifts, fire and water pumps. So as a general rule, you can see that the diversity in hospitals touches somewhere between 2.5 to, this is a very, general thumb rule, which need to be accurately worked out later probably. So you can expect a demand of 35 to 40% of the connected load in most of the hospital projects. So this is why I wanted to highlight this point. And if you look at the power requirements of the medical equipment, you can clearly see that every modern medical equipment is based on a digital platform. So digital platform means everything has a processor and system that is supporting the processor. So, which means in the case of a medical equipment which is working on digital platform, the power outage means restarts will be somewhere around 15 minutes at least. Maybe it can happen between 5 minutes to 15 minutes. So again, every time it is starting off, it is actually getting more and more susceptible to failure. So power outage means it's actually a very damaging thing for the medical equipment. So, which means the UPS systems are mandatory for all the medical equipment, most of the critical large value medical equipments. And again, many of the utilities like chillers, VFDs, pump controllers, and even they also have the digital platform, which is microprocessors. So they also these days are very sensitive to power outages. If you look at the other services like fire alarm, PA system, CCTV, access control, telephone and computer network, these are also, critical utilities which works on the digital platform. And I'm just showing you one of the smaller systems, which is also called the IP system. It's actually the isolated power supply system, also called the medical power supply system. Basically, it's an ungrounded system. So it will not work on a tripping basis. It will work on a power monitoring basis. So this is, as per the National Building Code, I mean, in India also we follow that. This is a critical utility for healthcare. So this is done based on the guidelines because tripping of an electrical mechanism which is supplying power and life support system for a patient is going to be damaging for the patient's health. So that's why this system in all our operation theaters as well as the ICUs, we provide this system for power distribution. It's called the IT power supply system. Okay, if you look at the, I just explained the power supply requirements and the type of loads and the equipment that is coming in for the electrical distribution for the hospital. Now, we will look at the standby power supply systems that is actually available and what is practically employed in our modern projects. We have the first item as the standby generator sets. We also have UPS systems, which is actually for the critical digital equipment. Then we have the inverter systems. So basically, it's a lower cost equipment compared to UPS systems. Basically, it feeds the lighting and non-critical emergency systems. Then we have the fourth category, which is the emergency generator. This is required only in the case of an emergency. It's not a standby system. It is an emergency system which is used only during an emergency. So we have these four different power supply systems which we need to elaborate and study in detail, which is what I have tried to highlight in the slide. So if you look at the changeover times of various equipment, you can see that there are bypass switches, which is actually a static bypass switches, which is tyrosine drive based bypass switch, which is the fastest, which closes in around 4 milliseconds. Then we have the automatic transfer switches for transferring power for the generators and utility and vice versa, which is actually a mechanical equipment which takes around 40 to 60 milliseconds. Similarly, there are inverter bypass relays, which is again shorter time, 10 to 20 milliseconds. You may not notice them. And we have, of course, the air circuit breakers, which may take somewhere between 40 to 60 milliseconds. So if you look at all these devices, so typical UPS changeover time, you may not even, the online UPS changeover time will be around 4 to maybe 6 milliseconds, which will not affect any of your digital equipment. Then we have the DG set changeover, which is again the start, stop, and synchronization and closing time, which may be somewhere around 20 to 45 seconds. So these are even the inverter changeover time is mentioned here. The next item is why a UPS, different reasons why a UPS system is required is basically a small slide which explains everything. It explains the power failure, the under voltage, all these things, type of problem. So whatever conditions, which are likely to affect your medical equipment, you can see that these are the reasons, environmental, human, everything. So in a nutshell, you can see that all the problems, all the reasons why the UPS is preferred in a healthcare facility. So the next one is basically what are the type of low voltage utilities depending on the which is powered by the or connected to the UPS system. We have the computer and telephone network, NIS call, PA systems, CCTV, IBMS. We have queue management systems. We may have displays and digital signage. All this will be, coming under the extra low voltage or low voltage systems category, which needs power from the UPS systems. So this is for regarding that. And this slide explains why a UPS system is required, and overall considerations for selecting a UPS. So the primary thing is it should meet the loads, and it should meet the power factor of the loads, and it should also maintain the power factor at the utility source, which means even irrespective of whatever may be the load which is connected to the UPS has the ability to correct the power factor at the input side. So basically to maintain this will be helpful for many of the problems related with the low power factor. And of course, there are the harmonics which need to be addressed, and also the surge arresters are also required to be connected to the UPS, which will protect the UPS from external surges. So basically, these are some of the requirements that you need for the UPS. So now, if you look at how do you select a UPS, the capacity of UPS, how do you select basically? To select a UPS, you need to find out the connected load. Then you have to work out the demand load that is coming in the UPS, and then add a spare capacity. Then if you look, and you should also look at the AC to AC efficiency. Basically, like what is the input power that is going in, and what is the output that is drawn by the load. So what is the percentage of the losses that is happening? And then you should also look at the quality of the UPS, because for a high value installation, you may be able to insist on a sine wave, because if you look at the cost and other parameters, for a very small installation, it may not be very economical compared to the true sine wave versus the square wave. So these are decisions the client can make depending on the quality of power that they need. And of course, the battery backup time, we give 15 to 20 minutes, because you always have the standby generators. We may be having power for a longer period. So, and other requirements is basically the surge protection, harmonic filters, isolation transformers, which is actually provides galvanic isolation. Again, these isolation transformers are required only if it is mandatory, because generally it again reduces the efficiency of the overall system. And then there are other parameters like the modular UPS versus the conventional UPS. And of course, the centralized UPS versus the distributed. Why I'm saying this centralized versus distributed is many of the medical equipment vendors bring this, dedicated UPS system to their thing. Again, this is actually one topic which need to be separately discussed, because again, it will be adding cost to the maintenance, because you have several batteries distributed in your building. It is always as good to have a centralized one feeding every equipment. This is why this point is discussed. Again, if you look at the block diagram of a UPS, you have an input power supply with the filter, then we have the rectifier and batteries, and the inverter, and again converter to the load. So basically, you have this AC to DC converter, which charges the battery, and from battery to inverter and back to the AC supply. So in this scenario, what you normally have is basically a normal line which actually have everything, and the batteries are permanently connected, which is on and off is done by digital systems. And again, there is a automatic bypass using static bypass switches, and also manual bypass. If the static bypass fails, you can have a manual bypass also. So this is generally most of the UPS systems are in this format, whether it is conventional or the modular UPS system. So this one, what I'm showing you right now, is basically the parallel redundant system, which is having two UPS systems working and one standby, and these are connected permanently, and batteries and outputs are connected to the same bus. So again, static bypass switches are provided, which can actually change over in a few milliseconds. So this configuration is used only for conventional UPS system. So basically, you have equal size UPSs connected to working, and plus n+1. So this is the general configuration what we have until now. Most of the maybe 10 years back also this system was there. And if you look at modular UPS system, how it works is basically you have modular, rack mounted system. Many of these systems are available as one standard unit, which can be parallel, and you can increase the capacity later also. So you have one system, and the what do you call it? We have this capability to. In the case of a modular UPS, the advantage is you have the capability to increase the capacity in future. We have the capability to replace a unit in the future, and net cost may not be much higher. And what the benefit is basically you have and also the higher efficiency. So most of the modern projects, I mean the new projects whichever we are having, many of them are having a lot of modular UPS systems compared to the conventional system. So we have two type of UPS systems. Basically the conventional one, which has been available for a long time, which works on an N+1 configuration, and we have the modular UPS system, which is having a fraction of the backup as an additional module. So and which has the extra flexibility of increasing the capacity later, or maybe you want to replace a damaged unit also is much easier. So it is maintenance point of view also. So we have some advantages for the modular UPS system. This is what I'm going to highlight. Again, how the changeover of UPS happening is what is explained here. In the case of a mains failure, it will isolate the supply and transfer loads to the battery. And similarly, in the case of the main power return resuming, you have the main supply is closed, and the control goes back to the mains. In the case of a failure, what happens is that the static bypass switches operates, and which is something like 4 to 5 milliseconds. So you may not even be able to find out whether it will not basically affect the loads that is actually feeding the system. So we have these three scenarios. One is the failure of the mains, another one is the resumption of the mains, and the failure of a UPS, which is handled by different systems within the UPS. So this is one point, one of the basic block components that is happening inside the UPS. And then we have the question of the type of batteries that you are using for the UPS. Basically, there are two types of batteries, as we know: conventional lead-acid batteries, and we also have the lithium-ion batteries, which is actually relatively new entrant into the market. And if you look at the specific benefits, compared to the cost per life cycle, the temperature withstand capability, and the discharge capabilities, lithium-ion goes up to, you can discharge them up to the 80%. And if you look at the charging cycles, it can go up to 3,600 or 4,000 charging cycles. So if you compare the total cost of ownership means if you buy a battery, you need to replace it in 3 years or 2 years. Fine. Then if you buy another battery, if it's going to last for 10 years, then the total cost of ownership, by 10 years, you would have replaced 3 sets of lead-acid batteries versus the lithium-ion. So which means even if you look at the cost of ownership, which is something like 15.8 per kilowatt hour versus 31 rupees per kilowatt hour, which is actually 50% the total ownership cost for a lithium-ion battery compared to lead-acid. But the thing is, the lead-acid batteries are actually much cheaper at this point of time. But then this aspect it needs to be considered. Another thing that is very important thing actually is the energy density of a lithium-ion is somewhere around 5 times that of a lead-acid. So which means it occupies that much lesser space. So if you look at any institution where you need space is a constraint, this will be the #1 priority. So apart from the cost of ownership and actually the lower cost of ownership for the lithium-ion, if you look at the total, these are the parameters you need to consider when you're actually looking at the type of batteries. At this point of time, lead-acid is a cheaper alternative, but then lithium-ion is still there. I mean, we have an excellent option if you have the initial extra, money to spend in this one. Similarly, again, these are actually a nutshell what is done. So, what is the cost? What is the capacity? Depth of discharge? Efficiency? You can look at all this, aspects of a lead-acid battery versus lithium-ion. So, it's again reproduced here. So that, this is one aspect which need to be considered later. For every, UPS backup system, this is actually a very viable option because all the other industries like your the automobile, even the laptops, everything comes with the demand now. So, okay, now that ends the part on the UPS system and the batteries. Then we have the generator systems. Okay, now how to install the generator basically is the location, the fuel storage, the capacities. Before I'll just go into the other part, which is actually So the first thing that you need to look at regarding the generator is whether it is full backup or partial backup. But then in the healthcare industry, basically it is mostly full backup. Then you should also look at the type of start and stop, whether it is automatic, whether it's manual or semi-automatic, auto sync, all that. Then we have the type of changeover, which can be ATS or circuit breakers. And then we should also look at the load management. Load management means, suppose you have a series of generators and you may not be needing all the generators at the same time. So depending on whatever your load is, you will be switching on. So, and what are the system you have switching on, whether it's manual or automatic, is another option. Then we have the synchronization. Basically, when you're paralleling the generator, it's called synchronizing. So synchronization of generator again is another aspect you need to look at when you're looking at the generator configuration. And again, the percentage of redundancy, like what generator you're keeping to, you're willing to invest in, keeping it as a redundant standby. Apart from the the capacity or configuration of generators, there are also a multiple array of fuels now, like LNG generators, dual fuel, all those things. And looking at the fuel also, you should also look at the storage requirements, because you definitely need to have at least a day's storage of fuel in the case of a healthcare facility, because your fuel supply may not be available near. If the fuel supply is not available nearby, it is going to affect the operations of the hospital. So fuel storage requirement is also another aspect you need to look at when you're selecting this standby generator configuration. So I've just highlighted one scheme. This scheme is basically, this is an electrical scheme which shows a transformer and a single generator with a transfer switch. So in this case, you just need to start and stop functions only. So you will be disconnecting the main supply and switching on the generator and connecting it to the main. So in the case of failure, for smaller systems, this configuration works well. You have only one generator, one transformer. You switch once the power fails, you switch on the generator. Then once the voltage and all the parameters are okay, you switch on the breaker, connecting the generator into the main bus. So this is how the connections work. So we have an automatic transfer switch and all that. This is the basic configuration. So in this case, you have only the automatic start and stop. But in the case of a standby generator with multiple generators, we have this configuration. So there are 3 generators and multiple loads. So how they work is basically depending on the percentage or fraction of the load that you need at that point of time, only then the generators will come on. So basically the first one will start and stop, and the second one will start if the load is required, and the third one will also start only the entire load is to be fed. And in the case of loads reducing, they will also switch off automatically. So basically you have an automatic start and stop, automatic synchronization, and automatic load sharing. So this is the second system. This is generally for large projects, they do this. So again, it saves the capital and operating cost when you're planning this fully automated systems. And again, this is another slide which explains the mains failure, the time delay for start, and because when the mains fail, you need to ensure that the failure is actually happening, which means if for a small surge and all, the generator should not start, then it should start the generator sequence, which will be starting the engine and building up the speed. Then once the voltage is built up, only you change over to the generator power. Similarly, the same sequence returns, but what important thing about switching off is you cannot switch off the generators just like that. You have to ensure that the generator runs for 2 to 3 minutes, so that the cooling systems are all distributed properly, and the water circulation, for the most of the water cooled engines, you need the water to be circulated and then cool down properly. Then only you should shut down. So the switching off sequence is basically including a no load operation. no load running, then only the generator shuts off. So this is the start and stop sequence of the during failure and resumption of the mains. Then I just want to highlight a few points on the categorization of the generator sets. There are actually 4 categories of generator. This is as per the ISO standards. It's called G1, G2, G3, and G4. So basically, in the case of a G1 rating, it is for all the generator general rated generators, which is applicable for domestic, residential, all that. So it is not supposed to be handling the sophisticated loads. And G2, if you look at, is a commercial generator. So most of the generators you buy are G2 standards. So you don't need to specifically mention that. So whatever you have is general, I mean, all smaller capacities also are G2 rated. But in the case of G3 rating, this is required because depending on the specific type and character of the loads, G3 is required because it's actually required for this is called for only in the case of hospitals and data centers. So if you are building a hospital, it is very important that you have this G3 rated generator sets, which can handle sudden shock loads without affecting the frequency or voltage while running. So this is an important point I wanted to highlight. And what is the difference between the G1, G2, G3 rating is I'm just explaining in the second and next slide. So you can see the G3 rating generators are much faster recovery, and the recovery band is around 2%. Also the load rejection also, if you compare, and the frequency drop, especially the frequency dip when you are switching off, is actually 3% for the G3 and 8% for the G1. So these are actually the international norms on standby generators, the classifications that you need to maintain. So definitely this is a factor which need to be considered for healthcare projects. I'm talking about the G3 rating. And another aspect regarding the generators, I'm actually taking up the power factor compensation part. So if you look at the power factor compensation, power factor is a utility driven parameter. Basically, if you reduce, if you are consuming power at a reduced power factor, the utilities will be penalize you, or you have to pay low power factor fine and all that. To avoid that, we generally give the automatic power factor controllers, which is actually required at the main panel only. But then what happens when the generators are running? So basically what happens when the generators are running is you need not to. So it was the common thought is you don't need to compensate for the power factor for the large loads. Actually, it's the other way around. Basically, when you compensate the large loads, which is not connected to the APFCR, like your large chillers, pumps and all, it will reduce the I2R losses. So our concept in our projects, what we do is it will drastically reduce, because it drastically reduces the energy losses in the cables. We put smaller fixed capacitors for all as compensation for all the large loads at the end of the system. And automatic power factor controller will be feeding the remaining, maybe up to 50% will be covered in the manual fixed capacitors, and 50% will be automatic. So it also reduces your investment on the automatic power factor system, which need to cater only the fluctuation. So it saves the I2R loss and reduces the load on the alternator. And if you look at the power factor aspect itself, even if you reduce the power factor, it will not reduce the fuel consumption. Rather, it will be reducing the KVA, but then the active power, which is actually kilowatt, remains the same for the engine. So basically, we recommend the system only for reducing the I2R losses in the cable and distribution system. Then another aspect is whether to connect the solar power in the case of a DG set. So we always recommend connecting the solar connection, solar power supply system while your DGs are working, because it drastically again reduces the fuel consumption of the DG set. So the only important thing is we have the controllers, which is basically the DG controllers, which should have the capability to handle EB power, DG power, and hybrid power with EB and DG and solar. So this is basically most of the new generation manufacturers of the DG controllers provide the hybrid system, which will save you a lot of cost on the diesel consumption. So this is one aspect I wanted to highlight. And another aspect is basically the dual fuel system. As you know, diesel is costing above, above of 100 rupees. And, the CNG costs somewhere around 65 to 75 rupees a liter. So these days, there are products available which you can use to convert your existing diesel generators into dual fuel system without by adding a few injectors and controllers. And the controller manufacturer themselves provide the warranty for the system. So this is, I've just highlighted one specific brand which provides the system, and worldwide this is happening. And so basically you can run the existing diesel generator sets at 30% of diesel versus 70% on CNG. And there is another option which is LNG, which is actually liquefied natural gas, which is actually 1:50 times more compressed than CNG. So you actually save on transportation, you actually save on operating costs, you actually, without the investment generally recovers. If you have an average 1 hour a day power per day, generally you recover in a year and a half. So the cost that you are spending. So these are the things, the second item that I wanted to specifically highlight. And that ends my session on the UPS and the generators. Now, what are the kind of maintenance that you need for the generators are what highlighted here. You need to check the fuel, lubrication, exhaust, battery systems. And similarly, the monthly inspection. What are you, during monthly inspections, it is supposed to be, this is international norms on, maintaining the health or preventive maintenance. So 30 minutes, it should be operated at 30% load, which is to be done monthly. And if it's a very large generator, you will not be able to have the 30% load. You can operate with available load for 30 minutes and yearly 50% for 30 continuous minutes once you can do, because you may have to bring in the load from outside, and 75%. So this is the testing norms for generator apart from the inspection. Similarly, for the UPS also, we need to maintain the various periodic inspection, which is quarterly, semi-annual, annual, biannual, and all that. And which need to be batteries need to be checked visually. It need to be the UPS equipment, the enclosure, as well as the terminals need to be cleaned. The cooling system, especially if it is a closed area, you need to have proper HVAC, AC units which is working properly, and of course the battery system. And similarly, you need to have the annual maintenance and biannual maintenance. All these are listed here. That one aspect, one important thing that you can actually utilize is the thermal scanners, which will detect the high temperatures and heat map basically to if some of the systems are not working. This will prevent failures in future. So this is what we do. So I have just highlighted in a last slide as a the standby power supply system for all different kind of equipment. So what need to be given UPS power, what goes on inverter, what is on standby. If you look at the emergency generators, you can see that firefighting, smoke extract, and fire alarm are connected to the emergency generators, which will be used only during the case of the entire system off in the case of a fire. So this is not for a backup system. It's only, so you can see these 4 different category of backup systems in operation here. So that more or less ends my presentation on this. So you can say that in a few words, you can say that standby power supply ensures the the continuity, reliability, and efficiency of healthcare installation. That's all from my side. Thank you. If you have any questions, you can. I think you can read out and I can answer.
Thank you, sir. Thank you. That was a very good insight into the various modes of our backup supply. I have a question here from Nazima Fatima. Can you explain how to carry out full load testing at hospitals for multiple generators?
Full load testing. See, basically, the big problem with full load testing in generators, you may not be able to switch on all the loads at the same time. See, basically, you have to bring in the water loads or whatever. So, practically speaking, if it's a very large installation, once it is totally installed, it is very difficult to do that.
So I suppose, sir, in a hospital setting, we don't normally have a full load. It's usually a partial load, right?
I know. See, the problem is full loads. You can do it one by one. That should not be a problem, right?
Okay.
If you have generators in a hospital or something, one of the generators you should be able to load.
Yeah.
Right.
So we can we can do it that in turns.
That's right. If you ask me everything switched on at the same time, it may not be practically. So what is generally done is before you shift the generators from the works, from where you're testing, you have to at extra cost before you ship it for installation from the factory. So we normally witness that actually. If we want specifically, they do that actually. 24-hour full load test separately.
Sure, sir. There's one question from Sarah. In a health facility with poor power quality, do you ever recommend some type of voltage stabilization system instead of a UPS system?
Which can you read out once? For which application?
Suppose a hospital has poor power quality. The input power quality is poor, and
Yeah. Okay. For poor power quality, if it's not a very large installation, medium size and all that, there are several systems. If it is a high installation, you should look at having a on-load tap changer and AVR. Okay, on the high voltage side. If it's a very small one, you can think of servo stabilizers. So this will provide you the solution for that. Yeah. Servo stabilizers. Yeah. Auto transfer stabilizers.
And there's one participant who has asked about the solar power for hospital purposes.
Yeah.
Any input on that?
Come again? Any?
They want your input on solar power for hospital purposes. How well can solar power be used here?
Yeah. See, this is my observation. We have worked on several. I have several clients who use solar power as backup. One challenge that we are seeing is basically, if you look at the solar panel, the area that you need, it may 1 kilowatt of solar power may need somewhere around with the modern efficient systems also 100 square feet a kilowatt. Okay, so but then your the building footprint or the area that you're able to provide to get the backup may not be there at the site. So we're able to achieve at the most, and if you install, suppose say 100 kilowatt as you install, it is an average of 4.5 to 5 units a day. So if you look at 100 kilowatts and what is going to compensate, if you need to have a serious compensation, it will be only 1/3 of what you're installing. So you have 100 kilowatt of a connected load, you need 300 kilowatt to compensate at least part of your electricity bill if you want to compensate 100% of this. So, and practically,
in that I'm not sure how it is in Kerala. But in Tamil Nadu, it seems that the environmental committee insists on 30% solar power.
Minimum. Yeah.
There's some mandatory requirement also, right?
Yeah. But that's mandatory. But at the same time, our challenge in most of the cases will be the footprint. Will not be sufficient to. But whatever area you can. Whatever area available you can do. You can also use your car parking if it is covered. But in cities and all that, it is very difficult. Very difficult to achieve. But I would always recommend your investment on solar is the most viable investment, which is something like 30% recovery a year. So whatever space available, whichever maybe the site, you should always give this as a priority. I'm talking about the solar system.
So there's one question from Abhimanyu. How to calculate the per bed consumption of electricity?
How to?
Calculate the per bed consumption of electricity.
1 second. Let me see. I cannot get the question. electricity.
So I think they are asking like, what is the power consumption rate? I think they are expecting a benchmark standard. How do you compare yourself with a benchmark? Electricity per bed, consumption per bed.
I can give you a figure on the demand. Okay. The demand, what we have seen is somewhere around, I'll tell you, somewhere around 4 kVA per bed.
Okay.
Okay. So if it is a 500 bed, it will be somewhere around 2000 kVA. I mean,
2000 kVA. That's an approximate number. Yeah.
Yeah. Somewhere I'm talking the demand, but then it may vary slightly, but then generally you can take this as a maximum. It may be even slightly lower also, but 4 kVA per bed will be a decent number.
So I have a question, sir. Just to like if say so the total demand is 3 megawatt, 3000 kVA.
Yeah.
So how do you design a generator? The combination of generator, can it be say 1000, 3000 or 2500, or which is, how do you decide on the combination? And second, if you're going to have a redundancy plan, say a backup generator, so how do you select the capacity of the backup generator?
Generator selection, actually I missed out one small point. Basically you have the when you're sizing the generators, there are something called you arrive at the demand, then you have the durations also, right? You have the duration because of 80%, 15% duration, or maybe it depends on the fuel quality and all that. So there is a duration on that, right? And then we have the basically the stocking of large equipment. You may have a chiller and all that, but generally, if it is above 3000 kV and all that, it is all ideally you should be looking at 3 working, and plus it is that capacity range. Why 3 working is, even if one fails, 2/3 of your your system is still live, which may cover. So even if one fails, it may not affect all your operations, and it will be extended for a longer time, because by then you find out your second one working, or get a replacement, or even the redundant one working actually. So ideally, we always say 3, but then it may not be always possible. But smaller installations you may be, because it may not be expensive, so you may have to go for 2, and for very large also you go for multiple. So it depends on the availability and the rating. So on a general rule, if you ask me, I would always recommend 3.
3, okay. And then how do you select the? So if it's like 3000, so it has to be the same 1000 as a backup generator, right?
It should be equal size. It's always better, because why I say, it may see the modern controllers takes 500, 1500, any size into that, but into the grid. I mean, they are able to handle the unequal synchronization and all that, if you're synchronizing anyway. But the problem is, if you want multiplicity, if one fails, if you want to use one part of one generator and cannibalize, or exchange a switch gear, everything is easy if you have everything same. Because healthcare, more than the efficiency, the most critical thing is the reliability and the stability of the system. And if you want and how fast you will be able to get that thing up and running. So equal size generators always have a point there, on reliability. How that's why that is done that way.
One, I think a couple of more questions. Is there any standard guideline for duration of the UPS backup in hospitals?
At this point, see, previous used to give 1 hour, 1.5 hours and all backup in hospitals. But then the present trend is, to give 15 to 20 minutes, because it doesn't. It's not only the backup thing. You have to answer the question whether the fuel is available, whether the kind of clinical procedure that's happening. So many other factors are needed. But then, if you ask me a guideline, as such, it is not there. It's not there. But I can recommend you. Presently, this is 15 to 20 is an accepted norm. Why? Because the standby systems are much more efficient, and the ability to handle the failure has improved a lot. So before, just never start. It is manual, and nobody will know also something has failed. So that is why the power backup time was much more. But now it doesn't make sense also to invest hugely on the batteries. Again, it's a dead investment. Take up electricity. Yeah.
And the last question, sir, from Abhimanyu again, for 100-bed hospitals, multi-specialty hospital with 20 beds for ICU, CCU, and SICU, NICU. So what would be the capacity of the generator? So that is something, it depends on the demand.
Right?
Not
very easy to answer.
So Abhimanyu, it has to be on the demand load. What is the total demand that your hospital requires? It's not just the 20 beds. So, but just to understand, sir, there is no standard formula, right, for this?
For finding out the capacity?
Yeah.
That's what, again, you cannot, because see, if you look at smaller size projects, no, this is 100 bed, right? 100 bed means it is not a small, it's a medium size, if you can say the modern ones and all that. I would always recommend this, this 4 to 5, 4 kVA per thumb rule, something like that. And it will be mostly 100. So it's 100% back. But if you add a scanning equipment, the entire formula goes.
Yeah, exactly.
If you add a, add a MRI, then the everything changes. So
yeah.
Rule without all these heavy equipments, you can say 4 kVA per per bed will be
Okay, sir. So thank you, sir. Thank you very much. That was a very enlightening session today. Thank you for sparing your day today. And friends, thank you for joining today. And